Okay, guys, I am going to try to take a minute and talk through some of the most common mistakes that I saw on the paper homework in hopes that you can use that feedback to adjust your responses and make sure that you are getting this process down. Because as I mentioned in the email, it is not a process that is going away. We will be doing some form of hypothesis testing for the rest of this semester. Hey, so some of the most common mistakes I saw, especially with the parameter under study, okay, when you are defining the parameter here, you must, absolutely must, under every circumstances, we're talking about a mean. So you are going to have to either write the word mu, or you are going to have to use the symbol for mu. You cannot simply put m. M is not an acceptable notation for mu. It's actually in mathematics, M is a notation for slope. So you cannot put that here absolutely under no circumstance. It must be mu equals or the word mu or the symbol. That is not negotiable. It must be there. If you just write out in words whatever this is without putting what symbol we're talking about, that would be incorrect. If you were to do that, you are not telling me, is this a mean? Is this a proportion? Is this a sample mean? Is it a population parameter? Without those symbols, that does not work. Okay. Now, in terms of how to define this, I've had a lot of you who did a very good job, and you have written in this is the mean farm size in Kansas. Okay. Now, first of all, we do want to use the word mean. We don't want to use the word average. I know average is in the prompt, but remember, mu is not defined as an average. It's defined as a mean. Most of us tend to think these are exactly the same. In most cases, they will be, but sometimes people use the word average very generally, and mean is more mathematically specific. Okay, so we want to say mean. A lot of you also added in the 1990s. Now, you do not want that. That does not go there. Okay. Why? We're trying to say something intelligent about a parameter we don't know. If you read this prompt, we knew what the mean was in 1990. It was 694. We are no longer talking about the 1990s. We are talking about today. This prompt wants to know if this data that we are given is enough evidence that farms are smaller now. The conclusion we're trying to draw is not about the 90s. It is about now. So that should not be there. Okay. So we either need mu equals mean farm size in Kansas. And a lot of you, I put on here that you also did the units in acres. Okay. You also could have had that with the symbol. Most of you did pretty good with one-sided or two-sided. This is a one-sided test because we're looking for smaller now. Okay. Null and alternative hypotheses. These went pretty well. The only way I saw an issue here was that if there was an issue up here. Again, you cannot use M. M is not an abbreviation for mu. You're either using the word mu, mu, or you are using the symbol mu, the Greek symbol. We are not using M. Okay, and we must have those equations and inequalities there. I saw everything looked pretty good up until we got to interpreting the p-value in context. Now, there was a lot of trouble with that interpretation. If you got that feedback that you were struggling with that, you want to go back and watch that slideshow again. Okay, p-value is the probability that of seeing a sample like ours if the null is true, is really the mean. Now, you can't just say that generally. You have to put it in context, okay? You can't say this is the probability of seeing a sample like mine if the null is true. While that is the textbook definition, it is not relevant to this situation. That's what the in context means, okay? So in a situation like this, my null value, of course, is going to be, and that's another thing to discuss. If there were any difficulties with writing the null and alternative hypotheses, it was because we had some people trying to use the sample mean as null, okay? The null value is a claim about a parameter, okay? The null value is a claim about mu, Okay. A sample mean is not mu. Now, we hope that it's pretty close, okay, but it is not mu. A sample mean is X bar. So if you are still somebody who does not know the differences in your symbols, you need to sit down with some flashcards, because that is not going away, and it's going to cause you to miss every single one of these if you do not understand what the difference between mu and X bar is. So that's something that's majorly important. 610 acres is not mu, and it is not our null, okay? Our sample is the evidence that supports the claim we make. It is not part of the claim itself. Okay, so here my null value is 694. Okay, my alternative, of course, is going to be less than that because these are smaller. So when we're down here and we're trying to interpret that p-value, okay, this should start out something like, if the mean farm size in Kansas is 494 acres, there is a blank probability, that's where my p-value goes, that I would see a sample with a mean farm size of 610 acres or lower. Okay, so what I'm basically saying is, if the null is really true, how weird is my sample? Okay, if my sample is really, really weird, like it's really unlikely to see that if the null is true, then I have some evidence to reject the null. That's why the lower the p-value, the more the evidence against the null. If it's going to tell me my sample is really, really, really unlikely, given that this is true, then I have to assume that this is really not true. Okay, I'm not going to assume that I beat all odds and I found the one really extremely weird sample. Okay, that's the interpretation of the p-value. It always needs to follow that format. If the null is true, that's what I'm saying here in context. If the mean farm size in Kansas is 494 acres, then here's your p-value. That's the probability that I would see a sample with what the information is from my sample or lower. Okay, this wouldn't just be the probability of seeing mine, it's also seeing something more extreme. So you probably don't want to travel too far away from that general skeleton, because sometimes when you're very new at this, if you're trying to say things in your own way, you get a little carried away and you say some words in there that put a meaning in there that you don't want it to actually mean. When it comes to type 1 and type 2 errors, this is really not a complicated thing, but what you have got to understand is that these do not mean we did the math wrong. They do not mean we made the confidence interval wrong. They do not mean we made the p-value wrong. It doesn't mean we interpreted it wrong. These errors are not about bad math. These errors happen when good math, okay, accurate calculations, just lead us to the wrong conclusion. Now, why does that happen? Well, because up here we said this is the probability of seeing a sample like mine if the null is true. Now, that probability can be very, very low. And what that means is most likely this is not the weird guy. It's just most likely that that's not true. But what if it is the weird sample, the one weird possibility? Then that means I made the correct mathematical choice, but it's going to lead me to the wrong conclusion. Now, what does this mean? A type 1 error. Most of you wrote things like, I rejected the null and I shouldn't have. Okay? Now, that is the definition of a type 1 error, but it is not in context. It does not tell us the significance in this scenario. Okay, I had some people write, it means that I said the null was in the confidence interval and it wasn't. It doesn't say anything about your confidence interval. It doesn't say anything about your calculations. That is completely incorrect. Okay, you should not be referring to your calculations at all. We're talking about in context. If you looked back at the claims, okay, remember our null value was, I'm just going to write this up here so we can remember it. Mu equals 694, right? I typed this wrong here too. It's 694 acres. My mu value is 694 acres. My alternative was mu is less than 694 acres. Okay, so I got those straightened out now based on the information. So let's look, yeah, that's correct. Okay, so if those are my claims, okay, and I'm looking at these errors, I rejected the null. So go look at your null. What did the null say? It said that the average farm size in Kansas now is 694 acres, and you rejected that. So what does that mean? You disagreed with this, right? So let's write down, that's what we said, okay? So we said that the farm size was less than 694 acres. Remember, when we reject the null, we reject it in favor of the alternative, okay? Now, that's wrong. That's why it's called an error, okay? In a type 1 error, this is what I said, and it was wrong. So if it was wrong, if the farms really were not less than 694 acres, what is the truth? They actually were not, okay? Now, you really don't want to say here that they were bigger, okay, because there's no language in this prompt about being bigger. You could say that there's no evidence to say that they're not exactly 694. That's technically true, but we don't want to try to say something that's not here. Okay, so let's go down and let's look at a type 2. Okay, so this is when we fail to reject, and we should have. Okay, so I didn't reject the null and I should have. So let's think about, what did we do? We did not reject this. We didn't get rid of it. We didn't throw it out. So what does that mean? It means we said the average farm size in Kansas was 694 acres, and they are not. They are smaller. Okay, so I should have rejected that. I didn't, so that means it, because I didn't, that's what I said. I said there, I accepted this null, or I didn't find enough evidence to throw it out. And I should have rejected it in favor of this. Okay, so that's what I did wrong. Okay, and this is what would have made it right. So if you're just saying stuff like this is not going to get you credit, not going to work. It has to be in context. It has to match up with that scenario. And if you do not do that, okay, then it is going to be wrong. Now, I'm not going to go through all of the similar questions on here. I wrote pretty detailed comments on every person's assignment that you turned in, okay? So I'm just going to pick out the parts in this question that are different than the first one that people seem to struggle with, okay? So the confidence interval. Most of you did not write the sentence interpreting it. Okay, if you did not do that, you lost a lot of points. Remember, there's a format for that. We are 95% confident that, okay, now here's where we're going to add our context. The mean weight of a bag of Ruffles is, and then here's where we're going to put our confidence interval notation. Blank and blank grams. Okay, so this has to be there. Pretty much has to follow the skeleton all of the time. If you're trying to get too far away from that, I encourage you not to do that, because odds are you're going to end up saying something that you don't intend to say, and it's going to cause you to miss it. Okay, now what does the confidence interval help you to conclude about the null? Obviously, this actually went pretty well. If it was in the null, we failed to reject. If it was not in the null, we rejected. Okay, now this R command, here is where I think we probably had the most people miss. Okay, now you guys realize, because this was a two-sided test, you were going to have some range of values here, and your region was going to be outside. Okay, most of you got that correct. And you knew that your mean, again, was the null, which is 28.3. And that standard deviation, of course, was going to be the sigma value we were given divided by the square root of 6. So 0.3287 divided by square root of 6. Okay, now, and of course, we'd like to see our graph. The biggest mistake that was made is that people pulled these two numbers from the confidence interval and they stuck those right there as the range. That is not where those come from. And that is not what they should be done. That's not what we're testing about here. Okay. So a p-value test is very different in terms of how we use it, okay, or what information that comes from it than a confidence interval. So this does not come from my confidence interval. Okay. Now, where does it come from? You know, it has to involve your sample. Okay. So let's go back up and look at our sample. Our sample was 28.98. Okay. So that's going to be one of the values here. Now, where does the other one come from? Ask yourself, look at this sample and compare it to the null. It's bigger than the null, right? But this is a two-sided test. So we have to worry about the true mean could possibly be bigger than the null. It also could be smaller than the null. So what we're going to do is we're going to figure out how far away our sample is from the mean. Okay, so if I take my calculator and I have 28.98 and I subtract 28.3, I see that it's 0.68 bigger than the mean. Okay, so I've got to compensate from that. I have to go on the other side of that. Since my sample was bigger, I need this other value has to be what's smaller. Okay, so I'm going to take my 28.3, that's the null, and I'm going to subtract 0.68. Okay, because my sample was that much above it. I want this to be a two-sided test, so I have to have a value that's that much below it. So that's where those numbers come from. They do not come from your confidence interval. They come from the fact that you have a sample value that's different than your mean. You want to test two-sided, so you're worried about being too much and you're also worried about being less than. So if whatever your sample is, you're going to find out how far away it is from the null, which we're calling the mean here. And if it's your sample is bigger, you want that much smaller than the null. If your sample happens to have a smaller mean, then you want to find the difference and then go that much higher than the mean as well. That's what that's going to come from. Okay, so that's how you ended up with the incorrect p-value there if you were trying to calculate that. Okay, again, I'm not going to address the rest of the concerns because they were exactly the same as interpreting them in the other side. So I hope that this helps clear up a little bit of the misconceptions and confusions that we're seeing in hypothesis testing.